Alright guys, a little disclaimer before we start digging into the content today. This video was made as a part of the coursework for CYBR 332 taught by Dr. Jennifer Grant. Additionally, due to the nature of the contents of this video, I am reminding you that the intent is for education and discussion, and that neither myself nor my institution are liable for damages that occur as a result of using the tools demonstrated today. With that being said, today we will be briefly covering Bluetooth and Bluetooth Low Energy and providing demonstrations on sniffing packets with both an NRF sniffer from Nordic Semiconductor and an Ubertooth 1 from Great Scott Gadgets. Links for those devices will be in the description below. Alright, moving on, we've got Bluetooth. Bluetooth is a radio frequency protocol operating on frequencies ranging between 2.4 and 2.485 gigahertz. The most common usage of Bluetooth is device-to-device data transfer. This type of transfer can be further split into various profiles or standardized usages. These are hands-free mode and advanced audio distribution. Hands-free is used for the remote operation of mobile devices, and advanced audio distribution is used for transmitting audio over Bluetooth. Bluetooth is also commonly used to monitor sensors and various small devices that you may use in smart home applications or as wearable accessories. There are two types of interfaces for Bluetooth: USB, which is primarily dongles that you would attach to a computer or a laptop that you have, and UART, which are integrated chips that are built into a device itself. Now we have Bluetooth Low Energy. Bluetooth Low Energy is also a radio frequency protocol. It operates in the same frequencies as Bluetooth, but can be used side by side, and its common uses here are proximity detection beacons. Think smart advertising. There's a beacon in a store, and when you walk past it, it sends a signal to an app on your phone. And smart accessories like heart rate monitors, things that are too small to have a traditional Bluetooth setup. And the main differences between Bluetooth and Bluetooth Low Energy are Bluetooth Low Energy is lower power. It doesn't take as much power to run. It's smaller, so it fits into smaller form factor devices. It has less data throughput, which means that it can't transmit as much data as traditional Bluetooth, and it also has a smaller range. That range is smaller because it doesn't have as much power usage as traditional Bluetooth. Alright, and these are some common devices that use Bluetooth or Bluetooth Low Energy. You see the Bluetooth devices, heavier data transfer. We've got printers, mobile phones, keyboards, mice. You've got all sorts of high data transfer accessories and devices that you would use for that. And then for Bluetooth Low Energy, we have smaller applications, things like heart rate monitors. Mobile phones also support Bluetooth Low Energy to connect to smart wearables. You have those proximity advertisement beacons that you see. If you've ever walked into a store and gotten an ad for that store, that was Bluetooth Low Energy. Alright, and next we'll cover the devices that we're using in our demonstrations today. First off, we have the Ubertooth 1, created by Mike Osman of Great Scott Gadgets. It's a small, low-cost device that came out in 2011, a time when most Bluetooth monitoring devices would have cost upwards of $10,000, sometimes even more. This was one of the first consumer-level Bluetooth monitoring devices. It was very affordable. You can still get them to this day. Very useful for sniffing Bluetooth packets, monitoring Bluetooth, and even intercepting and cracking Bluetooth packets. You can use it with Wireshark and Kismet. You can also write your own software. The entire thing is documented on their GitHub. And next, we've got the Nordic Semiconductor. This is the dongle version, and it's manufactured by Nordic Semiconductors. Again, it's another small, low-cost USB device. In this instance, it supports multiple IoT protocols: Bluetooth, Bluetooth Low Energy, Zigbee, all sorts of crazy stuff. And it comes with Nordic Semiconductor's NRF Connect, which is an application suite that provides a host of different applications for the NRF dongle. And again, this can also connect to Wireshark and Kismet. Alright guys, for our first little demonstration here, we're going to go ahead and open up our NRF Connect suite here. Give it a second to open, make it bigger. Alright, so as you can see, we've got all sorts of different apps that work with our NRF dongle right here. And the first one we're going to take a look at here is the Bluetooth Low Energy app. So we're going to pop this open here and give it a second to find our device. Then you want to make sure that the device that you select is the one that says Nordic Semiconductor NRF52 connectivity right here. You want to make sure that you've got the right device in, it won't work otherwise. And as you can see here, we can pop open some generic attributes here. You can open up here and change some parameters if you would like. You can change your advertising setups. But we're not going to worry about all that for today's video. Instead, we're going to come over here, hit Start Scan, and give that a second to find some devices. Should be good. There we go. And you can see here, we can see the details of these devices. And we can see their address type. We can see their advertising type, what services they offer, service data. Sometimes you get manufacturer-specific data. Very useful information if you're trying to figure out what's within range of you. And then let's take the PRBT here and we'll attempt a connection to that. Give it a second here. And as you can see, this particular device requires a passkey. And the NRF is not a cracking tool. So we're just going to ignore that for now. And I want to show you guys this right here. You can analyze your connection between the NRF and the device you're trying to connect right here. We can see this is a unencrypted link. We can see some attributes here and some other data about this particular device that we were trying to connect to. And then because we didn't enter the password in time, it disabled and disconnected. And we can see that down here on our log. And if you want to see or export your log, you can just click that right there. It'll open up the text file for you so you can analyze what exactly is going on. Alright, and then I also want to show you guys here a fancy little programming tool here. Same deal, open it up, give it a second to find the device, make sure you're using your Nordic Semiconductor device here. It'll let me click on that here. Looks like it's having a little bit of a problem. There we go. Alright, and you can see here we've got our bootloader, core application, master boot rank. You can see everything, file structure here. And all you need to do to reflash it is to add a hex file right here and run the write program right there. Very fancy, very useful little tool here in the NRF dongle. Alright, and now we're going to do our second demonstration. This is the Ubertooth 1 device, and this is actually a pre-recorded video I took on my Mac because I did not have enough ports for the device, my camera, and the microphone. So we'll play this back here. And the first thing we're going to do is pop open a terminal window. And we'll make it a little bit bigger so it's easier for you guys to see. And what we're going to do now is verify that our Ubertooth is working. So we're going to run the spectrum analysis tool to do that, and that's going to be Ubertooth-SpecAn-UI. And that'll pop open a nice little GUI tool right over here on our desktop. And what this is a 2.4 gigahertz band frequency analyzer. And that green line at the top there is 802.11b frequencies. And as you can see, we can make some marks, select out different peaks if we'd like, and it's a very handy little tool. Alright. And now we're going to pop open another terminal window. And we're going to get this working with Wireshark so we can actually get some good data out of it. And how we're going to do that is we are going to create a FIFO file right here. We're going to make a pipe /temp pipe, and as you can see, I already have one. It already exists. And what we're going to do now is tab into Wireshark. And so we'll open up Wireshark right here. And right up there at the top, we're going to hit that Settings button. Go down to Manage Interfaces, Pipes, and add that pipe that we just created. And all we're going to do is /temp/pipe right there, the location of that pipe. Going to add that in, scroll down to the bottom, make sure that it's checked, that it's going to get into the scan, and we're going to come back right over here, and now we've got to actually get our Ubertooth device to output data to that file. And we're going to do that by Ubertooth-BTLE-F-C, and then the location of our pipe, and as you can see, we've got all this crazy unreadable data here. So we'll tab back right over to Wireshark, where we can get that in a more readable format. And it works just like any other Wireshark scan. We've got all the packets showing up right here. You've got all the details down at the bottom. If you want to stop it, you can just hit stop right in the Wireshark application itself. No need to mess with the terminal for that. And we'll be able to go through and sort these and search through these like any normal Wireshark scan. And as you can see down here, we've got some data, we've got some advertiser data, manufacturing data. We can see that this is actually from an Apple device. And then as we scroll back up over here, we can see that we've got the Bluetooth source and destination right there, along with some other interesting data about this packet. Alright, that wraps up the video. Hopefully you all enjoyed this brief demonstration on sniffing Bluetooth and Bluetooth low energy packets. There will be instructions on installing the Ubertooth 1 in the description below. Thank you all for watching.